Now, if we're going in the opposite direction, we can use the rule that if a to the power of m over n is the same as the square root of, or the n root of a to the power of m, then if I'm given a radical, I can turn this into a rational power. All I'm going to do is I'm going to take the index and make it the denominator of my power. So this would be the same as a to the 5 over 3. And the index of 3 becomes my denominator for my power. I have a to the 2 over 5. For example C, it doesn't say what the index is, but we know when it doesn't write it, it's actually a 2 there. So this would be the same as a to the 9 over 2. For example D, this is the same as 1 over a to the 7 over 2. So if I'm writing this as a power and then evaluating what the number actually is, then this is the same as the inside part would be the same as 1296 to the power of 1 over 2, but then there's another radical around it, so this would also be to the power of 1 over 2. The 1 over 2 times 1 over 2 means that it's going to be 1296 to the power of 1 over 4. And whether I take the fourth root of it or say that it's going to be to the power of 1 over 4, my answer is still 6. For example 2, because this is in the denominator, then that's the same as 169 to the power of negative to move it up into the numerator, and then if I'm square rooting 1/2. And the actual value of that is going to be 1 over 13. For example C, it looks pretty similar to example A. This is the same as 64 to the 1/2 for the radical that's on the inside, and then when I apply the radical on the outside, it's all of that to the power of 1/3, which means that it's the same as 64 to the power of 1/6, which is actually just 2. For example 6, if I am writing each expression in the form of ax to the power of n, it wants me to just solve or simplify what my coefficient would be, and then have a power for my variable. So if that's true, then for the first one, I'm going to actually apply the index to the coefficient, and the cube root of 8 is actually just 2. And then that index is also going to become the denominator for my exponent for my variable. Same thing when I get to example B. For example B, then this is the same as the 5th root of 32 times the 5th root of x to the power of 3. 5th root of 32 is just 2, and the 5th root of x to the power of 3 is going to be x to the power of 3 over 5. For example C, the square root of 900 times the square root of x is the same as 30, and then x to the power of square root of x is just power of 1/2. For example D, I'm going to turn it into a fraction first. I'm going to say that this is going to be the same as x to the power of 5 over 3 times x to the power of 1 over 3. And when I'm multiplying those two things, I add it, so I get x to the power of 6 over 3, which is the same as just x to the power of 2. When I get to example E, I'm going to say that this is the same as 2 times x to the power of 1/2 times x to the power of 1/3. Well, those two don't have a common denominator. So the lowest common denominator is going to be 6. So I got to multiply the first one by 3, the second one by 2. And I'm going to say that this is equal to 2 x to the power of 3 over 6 times x to the power of 2 over 6, which is going to leave me with 2x to the 5 over 6. And for the last example, if I'm writing an equivalent expression using exponents, then I'm going to say for the first one, it would be the same as a to the 3 over 2 to the power of 1 over 2. So it's a to the power of 3 over 4. In the second case, it's the same as the cube root of 64 and v to the power of 6 over 3 to the power of 1 over 2. I can simplify this and say that it's going to be the cube root of 64 is going to be 4, and v to the 6 over 3 is the same as v to the 2, all to the power of 1 over 2. So I have the square root of 4 and v to the 2 over 2, or v to the power of 1, and it just winds up becoming 2v in the end. For example, C, I have x to the 5 over 4, y to the 3 over 4, all to the power of 3 over 2. So I'm going to multiply them, and I get x to the 5 times 3 is going to be 15, over 4 times 2 is going to be 8, and y to the 3 times 3 is going to be 9, and 4 times 2 is going to be 8. And I'm done. All right, that's it for this unit. Go ahead and get some practice.